writing. So have any of you written any papers before? Some of you, right? Okay, good. So in 2017, I think, so I met with the Dalai Lama because, he wanted, he called on some physicists to sort of teach physics to Buddhist monks. So we taught, all the things like quantum mechanics, quantum field theory, electrodynamics, quantum electrodynamics, all this to Buddhist monks, in the monastery. And these people don't have any formal education. They don't even know, of course they have common sense, but they haven't, they have been educated in, Buddhist texts and stuff, but they haven't had any, they haven't gone to a school. They don't even know, if you ask them, 1 over x is equal to 3, what is x? They don't know how to do that. They haven't had any formal training, but their logic is sound. So, it was a great challenge. And of course, the reason I'm showing you this is because, I want to show you how they learn. And it's a very interesting way of learning. So they have these Buddhist texts, they read them. And this is a video I shot with their permission. And what they do is then they have debates. There is no classroom teaching like this. You just read whatever text, then you go and you debate with your teacher. And every time you debate, you either ask a question or you define something. There's nothing else. So whatever you say, it has to either be a question or it has to be a definition. Or it could be a definition and a question, or a question and a definition, something like that. And then every time you finish, you do this, passing it on to the other person. So you can, if the video works, you can see how they do. The teachers are sitting right there, and that's the student. So they're debating. So he's doing that, meaning he's saying something and giving it off to the professor, and the professor keeps asking questions, right? So to give you an example, I participated in one of the discussions like this, and the question was, what's the most fundamental particle was the question they asked me. And then the question that I asked them back is, what is a part? Right? So what do you mean by part before you define particle? Right? So it's like that. You either ask a question or define something. The reason I'm showing this is that sincerely I feel that in today's teaching, the actual, you're getting trained. For example, I used to go to circus in my childhood, and the ringmaster would come and say, sit here, and the lion or the tiger would sit there or jump there. So you would call that well-trained, but you wouldn't call it well-educated, would you? Right? So we have to ask the question, are we being well-trained or are we being well-educated? Right? So there's a certain difference there, and I believe that this kind of discussion where, where we are more of interaction rather than me standing here and telling you, giving you my wisdom, right? You can become knowledgeable from my knowledge, but you cannot become wise from my wisdom, right? That you have to get it yourself. So in that sense, I'd like to ask some questions before we proceed to scientific writing. And those who are on Zoom, please feel free to unmute and answer. I cannot really see you because your videos are off. You don't have to turn your videos on or anything, but please feel free to answer any of the questions. So before we go to scientific writing, you can go to Google Scholar, and you can type scientific writing, and you will find so many papers, right? And then you can download them and read them to death, and then understand whatever it is. But even before that, what I like to think is, what is science? Because scientific writing. Right? Before you write about scientific writing, what is science? Or even, what is the modern scientific method? Or what is scientific method? Because you are sort of at the start line, really. I understand that some of you may have had prior research experience, and now you're getting some more, but you're really, you're really getting warmed up. And hopefully some of you would go to grad school, some of you would go to medical schools, or wherever your future takes you. You may not be in a position of graduate research assistant or a PhD student, but you're always doing your research and you're always writing. And it's scientific writing is, even if you're tweeting also involves scientific writing, right? It's not just writing a paper. So to talk about science more generally, what is journalism? Because you're going to write up a paper and submit it to a journal. And we have to ask ourselves that question: what is a journal? What is journalism? And what is the purpose of this? Is it just because I want to put it on my resume? Or is it because I want to inform somebody? Or what's the point? I mean, why should I write a paper? Right? Anybody? What is any of these questions? I want to hear from you. There's no wrong answer, so feel free to
The purpose of journalism,
Mm-hmm.
I think, is to record important events and sort of get to the root of the truth of phenomena.
Very good. I like the word truth. So, so she said, for those on Zoom who couldn't hear it, she mentioned that the purpose of journalism, a lot of things, but one word that I picked out from her answer is, truth, right? Anyone else? That she answered the last question. And people on Zoom, please feel free to chime in anytime. You had something to say.
Oh yeah, I think that science is a philosophical perspective used to explore the world using the logical means of science.
Okay, so what is the scientific method?
A series of logical steps to help differentiate between certain truths which are held consistent in your.
Right. So again, we came up with the same word, truth, right? So now, what is this truth?
Something that we can rely on in almost all, if not all, possible realities. So
All possible realities.
we can assume that no matter where I am, if I drop something, it will fall. So we consider the fact that things fall to be true, because in all testable realities and all testable scenarios in which one can do that thing, will get that expected result.
Very good, very good. So testable. So I would like to amend that a little bit. There are not multiple realities. There's only one reality. There are multiple scenarios, maybe, but it's the same reality. There's only one reality. Suppose there are two realities, then the second reality is a part of the first. Therefore, there's only one reality, right? So there's only one reality, and that's how science can be objective. If there are two realities, if your reality is yours, my reality is mine, there's no objectivity, right? And if there is no objectivity, then we're lost, right? So that's the first thing. So truth is confirmation of mind to reality, right? So we are understanding this reality around us. There is an objective reality, and we are understanding that. And modern scientific method, whatever you mentioned about logical steps, is in general, you can say it is, Aristotle did the same thing, Plato did the same thing, Socrates did the same thing, a couple of guys from India and China did the same thing. They've been doing it from ages, right? So what's so modern about it? You guys are, in the evolution of Homo sapiens, we consider ourselves as the epitome of, technological development. So what's so modern about the scientific method that we have?
We're sharing.
Sorry?
We're sharing all of our knowledge.
I mean, even in the olden days, they had shared it. So, Plato's Republic, you're reading it right now. So, and Aristotle's, yeah.
I think it is so.
Go ahead.
I think that the technological advances within the last 200 or 300 years have certain things about it have about exponential growth of technology. So at some point, we reached a threshold with things like the printing press that made knowledge more accessible to lots of people. Electricity, these things permit some foundational science that allow
But that's really, more about how we are, but it doesn't, how does that make the scientific method itself modern? I mean, the scientific method would still be whatever he mentioned, the logical steps. My question is, I agree that there have been all these technological developments that make our life better, easier, faster. I mean, make it possible for a guy who was educated 10,000 miles away to come here and teach you, right? So, like me from India, right? So all these are great, but it still doesn't tell me what is the modern scientific method. How does this, what's modern about our scientific method? I want you to think about it.
I think that it might be more integrated in terms of discipline communication. So the nature of the questions, although the same we learned said earlier science, but like maybe the statistics involved in something like biological analysis.
You're almost there. You're almost there. That's very good. So the way I would like to put it is the modern scientific method starts with Newton, right? Of course, before Newton, there have been a lot of people as well, but I say that it starts with Newton because Newton was one of those first people, not that there was nobody before Newton, but he was the one who rigorously translated whatever you have into a mathematical formalism that you can use to predict and validate. So often you hear that scientific method is you have a hypothesis and then you test something, right? And then you validate it. So how do hypothesis is not just a sentence. It's not just, not just something that you just think about it. It's much more rigorous in the modern scientific method. You can actually, for example, I can say the magnetic movement of a muon should be whatever, 1.3, 2, 3, 4, 5, 6, 7, 8, 9, right? And that's what I'm going to validate, right? And that mathematical formalism is what's modern and the modern scientific method. It doesn't have to just be an equation, right? For example, if you take Darwin's evolution or most of biology, right? You have schematics, right? Even those schematics or reaction schemes in chemistry, they're also a form of mathematics, right? So, and then of course there is statistics, right? So I would like to definitely recommend this book. I mean, it's nothing related to science, but as scientists, if you're going to become scientists, you have to don several hats, right? And then you have to be willing to take no credit, less salary, and be satisfied with it. And so one of those things is elements of journalism, because you have to know, you have to have not just read science textbooks. You have to have an all-round development, and for that, you need to know what journalism is, because a scientist is necessarily a journalist, because you're going to be publishing papers. Because when somebody says, oh, okay, Rama, what have you done? And then I say, okay, pull up my Google Scholar profile and look at all these papers, this great stuff that I published in all these journals, right? So it comes back to journals. So as a scientist, I do research in my lab, or I think of something, and then I'm writing it up and I'm publishing it in a journal, right? So I have some more, a little more rigorous definition here. What is science? Science is the rigorous study of physical things. So what is a physical thing? A physical thing is something that exists right now, but it can also change, right? There is existence and there is change. And so the modern scientific method has to do with putting mathematics to this, right? So you can test it, you can validate it, and naturally that involves statistics and schema. And like you mentioned, journalism is the activity of gathering, creating, and presenting information. And to inform is to enact. So when I inform, then it is the act of your mind knowing it. It sounds like philosophy, but believe me, if you do PhD, you're going to get doctors of philosophy, right? So you have to know this stuff. But that's what, nobody gives you any other degree, you get a PhD, right? So you don't get, a doctor of biology or doctor of physics or doctor of something else. You get doctor of philosophy, right? So, and the purpose of this journalism is to provide citizens with the information they need to make the best possible decisions about their lives. And people don't know it, but they're always looking to you guys, to scientists, to make those best possible decisions, be it economics, be it, COVID pandemic, be it anything else. And so as a scientist, you have to be really, really, really rigorous. And how can you be really, really be rigorous and keep your personal perspectives, subjectivity, not let that overwhelm the decisions, is by having objective definitions, by exercising that objectivity, and that objectivity comes from the modern scientific method right there. Because you may not like me, but if I say F is equal to ma, okay, Rama is a jerk, but F is equal to ma is right? So that's what the modern scientific method is about. And so if you are going to write papers, you're not writing papers because it's going to add to another thing on your resume, or it's going to make your grad school better, or it's going to get you a degree or whatever. Yeah, it will do all those things, but that's not the aim of it. The aim of writing a paper is to make sure that, whatever you have done is going out there and people have access to this. For example, this is very, very important. For example, let's say, in the last year, people have said you have to maintain the 6 feet distance between two people, right? And then suddenly you ask yourself, where did the 6 feet come from? I mean, there must be some objectivity there, right? So 6 feet. So why 6 feet? Why not 5.9 feet? Okay, 6 feet, a round number, fine. Why not 10 feet? Why not 5 feet? Why not 4 feet? Why 6 feet? Right? And then if you go back and dig, you would go back to a paper in 1920s where some guy was studying aerosols, and they decided that the threshold size to categorize these aerosols as some random number, 5 microns. Below 5 microns is aerosol, above 5 microns it's not, right? So 4.99 aerosol, 5.01 not an aerosol. So it comes from there, but then you ask yourself, oh, why did they decide on this 5 microns? It appears completely random, right? So people have been practicing social distance. They wear masks, they go outside, but they get infected because that 6 feet doesn't do anything, right? So it's not that I'm not trying to say that you should maintain a lot of social distance. 6 feet is also not enough. Is what I'm trying to say. That you should really be careful, right? So you have to think about where these come from. So the reason I gave that example is here, that need to make the best possible decisions about their lives, societies, and their governments, right? As John Galt puts it in The Fountainhead, people won't, they don't know scientists, they don't know, they just know scientists as a generic word. They don't know who these scientists are. If you go to, for example, there's a research organization called Pew, PW. They have done a survey among Americans, and they asked how many of them trust science. Everybody trusts science, right? A lot of them trust science, the majority. Then they asked them, name 2 living scientists. Do you know who got the first place? Sorry? Einstein. Living scientists. Yeah. But Einstein got the second place though. But the first place went to Bill Gates. Sorry? Exactly, right? So Bill Gates is not a scientist. Yeah, but that's not a scientist. No. So it's like that. So you have to, think more deeply about scientific writing. It's not just an exercise of, writing and publishing something for the sake of it. It's a sacred act. And you have to take it extremely seriously, not just scientific writing, science itself and your research itself, right? So the reason for that is reality alone is the ultimate arbiter of truth, not you, not me. And if scientists don't do a good job, then Twitter becomes the ultimate arbiter. But we don't want that, right? So we don't want somebody on Twitter saying that, oh, this is wrong, right? Or that is right. Sure, people should participate in discussion, but the aim of scientific writing is that it's not Twitter, that you cannot just say whatever you want, but you have to present a scientific analysis of whatever you find, whatever you have, right? So that's the goal of scientific writing. Any questions so far? Yes.
So how do you define a scientist?
So a scientist is anybody who does science. Science is the rigorous study of physical things. So I would call my daughter a scientist, right? But living scientist, as in the profession of scientist, that was the question. But Bill Gates is not a living scientist whose profession is, he's an entrepreneur, but he's not a real scientist, as in he's not doing any research, right? So, but science in general is any type of knowledge. So all of us, whether we want it or not, are scientists. But unless you think a little more deeply and realize that you're a scientist, that you're rigorously studying these physical things, that's how I would define a scientist. Any other questions? Okay, so the first thing that you have to think is, is the paper worth writing. Even before is the paper worth writing, the thing is that is this piece of work that I'm going to dedicate so many minutes and hours and days of my life, is it really worth it? But am I doing something without knowing what it is? I went through this. I mean, there were nights where I was a fresh grad student. I would just burn midnight oil, and I would think, I mean, what am I doing? I mean, what does this mean? And it's natural question, and you should encourage it, and you should think about it very seriously, because groundbreaking work can only come from there. So is the paper worth writing? So first you have to check what's in the literature. I already showed you Google Scholar. So you can go to Google Scholar, and then you can say, type out whatever you want, whatever is in your head. And there is a thing here that you have to note, that whenever you're searching, literature search is a really tricky thing, because you may not know, as a newbie or as someone who is, for example, you are entering a new field, you may not know the right jargon. You may have, for example, let's say you want to study how, if a soap bubble is expanding and you want to see how it expands, you may naively type, how does a soap bubble expand? And that may not show any results, right? Because you may have to Google, manifold dynamics of curved surfaces and the calculus of moving surfaces or something like that, which is what actually, how a soap bubble expands. So you need to really know, what those terms are. So you have to talk to people. That's why we go to conferences and interact with people and know these keywords, right? And that's how you search the literature. So make sure that you got all the keywords right, and look up what's in the literature, because there's a pretty good chance that the question that you have has already been answered, right? And you want to make sure whether there's an answer or not already. If there is none, then you could. The question that I say is, so what? I mean, it's a really important question. So what? Right? I mean, you don't need to have any application as such, but I'm not saying whatever you're doing must result in a product that people are going to use right away. But it's not like that. But so what? Like, for example, the Riemannian hypothesis is not proved. So what? So what? So what if Riemannian hypothesis is not proved? Right? I'm not saying it's not important. You have to ask yourself that question. I'm doing this thesis, so what? Right? Because when you're writing a scientific paper, what you're trying to do is you're trying to explain to someone else what you have done. Then you have to first tell them why it is important. Right? Otherwise, journals get papers from so many people. For example, I'm an editor on one of these journals, but we get papers. There are so many papers, like 200, 300 papers that are submitted every day, or there's so many people, right? And then I mean, why should the journal choose your paper and why should they publish it? And this comes from sort of old practices. In the olden days, we were talking about before. Now you have internet and now you have this thing. Journal is really doesn't need to be printed, and you can put as many papers as possible. But in the olden days, all the journals used to be printed and they had only so much place. They could only fit in so many articles. And a lot of journals still follow this, that they can only fit in so many articles in an issue, right? So if I can fit in 10 articles in my monthly issue, why should I pick yours, right? Of course, once I decide that I pick yours, so there are a lot of journals that don't even send your paper out for review. So you submit it to the journal, then the journal editorial board decides if this paper is worth sending out for review. And a lot of papers, 70 to 80% of the papers are rejected right there, that the journal says we're not even interested in sending this out for review. You may find another journal to submit your paper. And then if they do send it out for review, then the reviewers look at it and they look at the scientific rigor and they comment, and then it goes back and forth, and we'll discuss that in a minute. But that's where you impress upon the editor or whoever. So what? Why your paper, why whatever you're writing, why whatever you're working on, it's so important, or why it deserves to be published in that journal. Unless you know it, you cannot tell that, right? And the suggestion that I had is you will read this, for example, if whatever project you are working on right now, I'm sure that you have read so many papers about it, and you may have seen in the introduction, that in each paper they introduce something and then they talk about it and then they say, however, this has not been researched about, or that has not been researched about. That's just just stating the facts, but why? Why should it be researched? So what? Yeah, sure, it has not been researched, right? But why? Try to think about that. And it's a lot of work to write a paper. Usually you go through several drafts, you go through several revisions. It's usually, let's say, 5 pages long for a short paper, short communication. Then you write it, and then there are going to be a couple of other authors. If you can write it alone too, if you are the only person who has done everything, right? Then that's great. But even for a single author, it's a lot of work, right? So you have to really think and know what you're doing, and the reference sort of getting blocked. So I've taken this from how to write a scientific paper, and of course Dr. Alper is going to send this presentation out, and along with it some more papers like one of those. But you can go to Google Scholar and just put scientific writing and get all those. So then you have to say, what do I have to say? So science is a performing art, really. Right, so you have to think about what you want to say, because I can see that already some of you may be bored, listening to me standing here and lecturing you. But it's the same thing. Like when I get a paper to review, I open it. Okay, yeah, sure, right. So you have to think about the story that you're telling, right? So you have to tell the story in such a way that when a naive person, a layman is reading it, layman, when I say layman, somebody with scientific education, but not necessarily in your field. For example, a bio person who knows, basic science, reading maybe some other paper in some other field, right? So you have, necessary scientific education, but not necessarily familiarity with another field. That person should be able to understand it. But there are also people who are in the same field who are going to be reading your paper, right? For example, if you're working in, let's say, nano sensors, so there may be people from nano sensors who are reading your paper, and they don't want to be bothered with all these nitty-gritty details, microscopic details, because they already know it, right? So for example, you don't have to define what DNA is. You can just say DNA and people get it, right? So you have to write this paper for a lot of different people, but it's only one paper, right? So the first thing that I always suggest is, write it for yourself as a single question or a set of questions, right? And write the answer for it. So write it down either as a single question or a set of questions. And when you write this question, you must know what each and every word in that means. Don't assume that you know it. Don't mistake familiarity with understanding. You may be familiar with the term, but do you really understand it? That's what you have to ask yourselves, right? And write down that question. Think about, how you're going to answer it and how you are going to show that this is the right adequate answer. If it is not the adequate answer and you don't have the capability, how are you going to justify, what else needs to be done to get to this thing? For example, let's say you have picked a question, you have thought about so what, and it's all important and all these things. And you have done some experiments or some simulations or whatever, and then you have some answers, but you need to do something else to come up with the final answer or something like that. So then, you have some evidence to say, oh, this is the direction we should be going in. This is how we should be looking at it. But we're not yet at the final step, but this is the direction. The next step would go this way. That is still an answer. And, a negative result is still an answer. For example, if your hypothesis is something and then you showed that your experiment showed that, oh, that's wrong, then that's also a result, right? So you have to frame your question in such a way that then, you can show your results to answer that question. And just use 3 simple sentences. Write it down in 3 simple sentences. And a good way to do this is think about telling it to somebody who is not in your field in simple sentences, right? And that gives you a very good insight by yourself. But you can watch this. It's called Yes Minister. It's a British show. If you YouTube Yes Minister leading with questions, how to lie with statistics, right? So and there's also a book, How to Lie with Statistics. That's a pretty good book that you all should read. And so statistics could really be very, very misleading, right? So you need to understand what these statistics mean before you decide how they because you're looking at whether this data gives you the adequate things for having the final answer or not. So you need to understand whether really, what the crux of this data is, whether you have, what this error means, what this deviation means, whether your statistics is right. For example, let's take the vaccine trials, right? Vaccine trials in phase 3, how is it done, right? So you go up and then you have these 30,000 or 40,000 or whatever number of participants, right? And then each of them has a hazard. Hazard is risk times exposure. You have a certain risk, right, based on yourself, and then you have a certain thing for exposure, right? You may get exposed to a virus or something like that. So they get the jab and they go back into the general population, and then a nurse would have a different risk and a different exposure than a retired person who is sitting at home in a lockdown, right? And then we use this to say, oh, the vaccine is 95% efficacy. What does that mean? I'm not saying that the vaccine is, I have taken vaccine, please don't. This is again, we must be very careful not to pigeonhole people. So I'm not an anti-vaxxer or anything. I'm a proper practicing physicist. So please, I have taken my vaccines. I'm not urging anybody not to take vaccines. So I just, for the record, but the reason I'm saying it is we have to think about it, right? What does that mean? That 95% efficacy means what? When just randomization, or what is randomness? Because all the statistics seem to be relying on randomness. How would you define randomness? Is randomness causeless? Is randomness has no cause? If it has no cause, then it's irrational. If it's irrational, then you're saying that you're using an irrational thing to rationalize an answer for your, rational question, which becomes irrational, right? So you have to think more deeply about statistics. These are not. Don't just be caught in a rat race. That's what I want to tell you. Don't just be running. Don't do that. It's neither good for you nor good for the society, no, for nobody. So don't just be caught in a rat race. Stop and think, what does this really mean? And that's what you're here for. Don't become well-trained, become well-educated. Right? And then, so now, then you have to decide, once you have done all these questions, you have to decide really what is the right format for this message. There are different kinds of papers. There are short communications where you write something in 3-4 pages versus long review articles that go on for 30-40 pages, and somewhere in between. So it really depends upon what is your question and what you want to write about it. For example, again, let's take the pandemic example. You're working on a thing, and then you come up with a sensor that can easily sense COVID from sputum, right? And then you don't want to sit and write a 30-page article on it, but you want to write something that can be rapidly published so that it can go out into the market and be applied right away, right? So you want a rapid communication. So that's a thing that in the scientific journals. A rapid communication is something that's 3-4 pages long, and then there are letters. So you can write a letter, you can write a rapid communication or a short communication, and then you can follow it up with more nitty-gritty details in a longer paper, right? So you decide on that, and you have to decide on the right audience. So that helps you pick the journal. Which journal should I choose? And here, to choose which journal, you Google the journals in your field, and you can go and see each journal has, you can do this with a couple of journals that, any papers that you read, go to the journal. And for example, let's say Journal of Physical Chemistry C. Go to the journal and see aims and scope. Each journal would have aims and scope. See what are the aims and scope of that journal, right? And based on that, you think about how to write it. And most of the journals would tell you, how to write it. And you can ask your mentor or other senior researchers. And then there is another thing called impact factor. Take this with a grain of salt. Impact factor is a quantitative metric that is often used in journals to see how prestigious a specific journal is. For example, this impact factor comes from, you publish papers, and then if I am doing some research work, I'm going to cite a lot of other papers I have referred to, right? So your paper is going to accumulate citations, and some papers accumulate more citations than others, right? So the impact factor basically considers average number of citations per paper published in the journal. So often it is considered that the higher the impact factor, the better the journal. But that's not really, that's not really true. But people often think about it that way, because somebody could write a review article. It may not be original research. I could just be summing up whatever is done in the field, and that may get a lot of citations. But it's nothing original, right? So you have to take it with a grain of salt. And when you submit, it can get rejected, right? Like I said, right at the door. They may not even send it out for review, and then they can send it out for review, and then you may have to revise it further, and then you have to think about what you're going to do. And then this is how impact factors are calculated for journals, and it's very, very good to know what the journal impact factors are. You could just use Google Scholar, or Clemson has access to something called Web of Knowledge, and you can go there and get the journal impact factors. It basically tells you average citations. So you think about this as a critical argument, and then you have, like I said, the statement of the problem, always posing a question. What is a question or set of questions that you're posing, and what's your evidence, or how to, what are you seeing? Like, I don't have the full evidence, but you should go in this direction, or what that is, and how you're going to present it, what are the strengths and what are the weaknesses. Often people, what they think is that you have to be 100% strong. No, that's not necessarily true. In a scientific paper, if your methodology, because, for example, I'm doing a study where I start out with a certain experimental design, and I'm doing this, and then I realized that I should have done something else, that I should have taken maybe n is equal to 10 instead of n is equal to 5. But now I cannot do anything about it, because now if I start taking n is equal to 10, I have to repeat all these experiments that I have done for a year, which is going to take another year. And then even then I would be comparing apples to oranges, let's say. So then that's what I'm going to say. Be open about it. Don't sweep it under the rug. A lot of scientists, believe me or not, subconsciously sweep it under the rug. Don't do it, right? And present proper evidence shows strengths and weaknesses. And like I said, literature search is the main thing. And the title page, when you get to writing it, think about what the title is going to be. And think about the number of authors, who is going to be an author on it, and what is the order in which they are going to be. Usually, the first author is the person who has done most of the work. And the first author is the person who writes the paper, and then other authors, based on how, for example, let's say, Autumn is doing experiment in my lab, and let's say my grad student is helping her. So my grad student, whoever is helping her, set up some stuff, would obviously, based on the work that he does, would be a contributing author on the paper, but he won't be the first author, right? Because she does most of the work. And then, of course, I will be, if I contribute to writing all the paper and things, then I would be an author on the paper. And obviously, I will be an author because I'm providing the stuff and my ideas and things like that, right? So you have to decide who is going to be an author, and you have to have an open discussion about it even before you begin writing the paper. And this is really, really important because avoid hurting feelings. You will see this more and more if you're in research, and you have to. It's good to have open communication and decide who is going to be first authors and establish responsibilities in paper writing. That is, for example, if there are a couple of people, if there are two of you who are working together, right, and then you're writing a paper together, then you can share responsibilities, right? That, okay, you write this part of the method section, I'm going to write this part of the method section, then we will bring it together. So do that first, even before you write. So first do thinking, and then once you have answered all those so what and all those questions, what the title is going to be, who are the authors, and avoid hurting feelings. So have an open discussion with your mentors or with others, and always you have it in a copy everyone in the email chain, and even if the way I have seen it in my life is I don't really care where I am on the author list, but you shouldn't do that. I'm not saying you should do that, but eventually if you're good, eventually you'll get papers. But a lot of times there would be all these things in a lab, and I have been personally a victim of these in so many labs, but it's okay, right? The important thing is not to get hurt, and these are part and parcel of life, but to deal with them in an open way, right? So you talk to your mentor and have an open communication and justify in a proper way why you think you deserve to be an author on the paper, or why you think you deserve to be a first author or a second author, whatever it is, right? So do that, and you will see this a lot in life. So the process is make the figures first. So think about your paper, think about whatever you're going to write. So I like to say, make 5 figures. Make 5 figures that are going to explain all the data in your paper. The first figure, what is the first figure? Second figure, third figure, fourth figure, fifth figure. And think about writing the captions for these figures. So next time you're reading a paper, don't read the introduction, don't read anything, just read figures and figure captions. See if you understand it. Just by reading figure and figure caption. If you understand the paper by reading the figure and figure captions, the paper is written very well, right? And of course, you're good too, right? So because you understand other stuff, right? So that's how you write a paper. Like I said, it's going to be one paper for a layman. It's going to be the same paper for the expert in that field. So the expert in the field is just going to go through those figures and read those figure captions. And these figure captions have to be so consistent. They have to have everything in it. And yet they have to be only 4 sentences, right? So that's an art. And so practice that art. And so make those figures, and those figures will tell you how you're going to tell the story, because it's not always a linear screenplay, right? So if you're a Tarantino fan, right, then non-linear screenplay, that you show something first, and then somebody else is robbing a bank, and then suddenly you switch to a scene. I'm obviously referring to Pulp Fiction. You guys don't watch movies, or am I not making any sense?
Pulp Fiction?
Yeah, I mean Pulp Fiction, two people are robbing a bank, and it doesn't make any sense, and it changes to something else, and then halfway through the movie you get back to the robbing scene, right? So it's like that, right? So a paper could be like that, right? So you show some graph in the beginning, it doesn't make any sense. Why are these people robbing a bank, right? And then suddenly you describe all these things, and then you go back and you talk about that, right? So it could be like that, or it could be a linear screenplay, right? But don't write it like Nolan. Nobody understands it, right? So and it doesn't make any sense. So write it in such a way that one figure, it doesn't have to be one figure comes after another figure, but once you read all the figures, you should know what the story is and what you're telling. So make the figures first and know the story, and that's creating the outline. And one important thing is have proper file names with dates. I have seen many grad students do paper. That could be the file name. That's not going to save you. Paper is a bad file name. So save it with your initials, right? And have a date. And if you're using Word or Overleaf or whichever software you're using, make sure your name is fully there as the editor. So when you write a comment, it doesn't show Microsoft user, right? That it shows your name. Right, it's very, very important, because when you're editing the papers, right, that it's your comment, but like, for example, I get papers as an advisor, and there are like 4 people who have gone before it. Then there is Microsoft user and Microsoft user. I don't know who these Microsoft users are. Of course, after some time, some familiarity with grad students, I can figure out who this guy is. But it's always important to name, who you are, and so that there's also a record. And make tables and figures early. Figures are the most important thing. So you are also going to be making posters for your REU. So think about the posters that you're going to make. You may have seen some posters in your own labs that you're working in, and then look at a poster, see how they're saying, what they're saying in the abstract, how the figures are, and think about how your final piece is going to be, what your final product is going to be, and weave that story in your head. Because as you're weaving that story in your head to yourself, you would be coming up with, oh, that really doesn't justify everything. I need to do this, right? And be brave to ask questions. Don't just say, oh, okay, it must be something, my mentor may know something more, I may not know. Be brave and ask questions. It's okay, right? And keep good deadlines, right? For example, especially this goes to autumn, deadlines, always have deadlines, because I'm a person who doesn't respond to deadlines, because I have a lot of papers, and then you're working on this paper. It's really hard to shift gears and work papers. So work with your mentor to establish prior deadlines, right? So that you get the paper out. That's the most important thing, right? And draw audience in your introduction, right? And identify the gaps in knowledge. Oh, we're running out of time. So, but method section, you be very thorough, right? And use past tense in method section. So when you are referring to, make